Hey, welcome back to Caroline's Chemistry. Today we're taking on a classic exam favourite, how to calculate formula mass. It's one of those simple marks you don't want to lose, but loads of students get tripped up by it in multi-step questions. In this quick video, I'll show you exactly how to work it out, how to use the periodic table to find atomic masses, and how to avoid those easy mistakes. If that sounds helpful, hit subscribe now and let's get stuck in. Let's start out with some pesky definitions. Now, I don't know about you, but when I was studying GCSE and A-level chemistry, I actually had no idea what these definitions meant. But they're super straightforward and are going to help you understand what it is that you're actually working out. So your official definition, relative atomic mass, is the average mass of all the isotopes of an element relative to 1/12 the mass of a carbon-12 atom. What does that mean? Okay, well, relative means compared to. And what we have in chemistry is an agreed standard, i.e., scientists have agreed we are comparing everything to carbon. And also think for me, what is 1/12 of 12? Well, 12 divided by 12 is 1. So what this definition is actually saying is we are going to compare everything to carbon and we're going to call carbon 1. It doesn't matter what its actual mass is. So for example, let's say that I am the agreed standard in a room full of people. Now, it doesn't matter what my actual mass is. Don't care. Instead, let's call me 1. Now let's pretend the student number 1 over there is 3 times my mass. Well, if I am 1, here's 3. A student over there, they are 10 times my mass. Well, that means I am 1 and they are 10. Another student over there is half my mass. That means I am 1 and they are 0.5. So it gives us a really easy comparison for masses without actually having to work with very big or very small numbers. Same idea, therefore, for relative molecular mass, but rather than comparing the mass of atoms to carbon, we're comparing the mass of a molecule. So there, our official definition is average mass of a molecule relative to, compared to, 1/12 the mass of a carbon-12 atom. If you are asked to give the official definitions, do not miss words out. Don't say, for instance, 1/12 the mass of a carbon atom, because you've actually missed a lot of words out there. It's compared to 1/12 the mass of a carbon-12 atom. Okay, now let's look at what we're actually going to do with these. So we're going to calculate some MRs. And the way that we do that is we add up all of the relative atomic masses for all of the atoms or ions shown in the formula. Quick little note, and they can ask this in an exam. It's a great question that can really trick people out. And the question says something like, relative atomic masses can be decimals, but mass numbers can only be whole numbers. Why? Explain this. Pause if you want a quick think, and then press play when you're ready to find out. So it's because mass numbers are the number of protons added to the number of neutrons. That means you cannot have anything but a whole number because you can't have half of a subatomic particle. You can only have whole numbers. Relative atomic masses, though, are averages, and they're averages of the different isotopes present of an element, for instance, which means you can therefore have 36.8, 25.2, etc., because they are averages. Starting off with hydrogen, which is 2 lots of 1, add the 1 oxygen, 16, and that gives us 18. Secondly, copper is an element, so we're just reading off the periodic table, 63.5. Then for the H2SO4, we have 2 hydrogens, so 2 lots of 1. Add that to 1 sulfur, 32, and add that to 4 oxygens, 4 lots of 16. That gives us 98. And then here we need to take into account the brackets. So the magnesium, first of all, just one of those, that's 24. Then we have to times everything inside the bracket by that 2. So therefore we have 2 nitrogens, 1 inside the bracket times by the 2 outside, so 2 in total. Add that to 2 lots of 3 oxygens, so that's 6 oxygens, 6 lots of 16. Add all of those together and we get 148 as our answer. So now we've worked some through together, here is your turn. So make sure that you grab yourself something to write with, hit pause on the video so that you can really work them out, get yourself a periodic table and a calculator. And then when you're ready and you've had a go, come back, press play, and we'll check the answers. Okay, so here are the answers for those 8 test yourself questions. If you need a little bit more time just to absorb them, then press pause and have a good look through. Note the way that I have written it, which is a little bit space saving. So 2 brackets 19 means 2 times 19, which is the 38. Now let's look at some common mistakes. So common mistakes, don't rely on your memory. Use the exact numbers off the periodic table. Now at GCSE, these are often given as whole numbers, but be aware that some exam boards, when they provide you with a data sheet with a periodic table on, sometimes those numbers, those relative atomic masses, can be to 1 decimal place. Don't start rounding them. So make sure that you use that whole exact number. The second point, and probably the most important one that's going to apply for every single calculations question in chemistry, is show your workings. This is not maths. And that means that we need to understand, examiners need to understand that you know what the numbers that you are writing down mean, which means show everything and label everything when we get that far in terms of what your working is. And then finally, brackets, what they mean is that you have to multiply everything inside the bracket with the number outside of the bracket. So if you have NO3 brackets 3, then that means you are timesing everything in the bracket, the NO3, by the 3 that is outside of that bracket, which would leave you in this case with 9 oxygens and 3 nitrogens. Thanks so much for watching, and if this was helpful, don't forget to hit subscribe now for new GCSE and A-level chemistry videos every single week. I look forward to joining you in the next video.